Good morning to all of you. Today I will start with the integration of complex function. Integration of complex function. Okay, so first topic in it is definite integral. So you already know about the definite integral in for the real valued function. Here we will talk about the function which is complex valued. So how we will find the integral, definite integral for it. Suppose that we have a function phi t. This is the function from real domain to complex plane. And this function is of the type we can represent it like, because it is complex valued function and t is a real variable, this function will be mapped in C plane. So its complex value is like this. We can represent this function phi t like this. Phi1t plus iota phi2t, where this phi1t and phi2t is real valued function, and domain for this function is interval a to b, where this t belongs to this interval a to b for all t in this interval. Okay, so this function phi t, which is the complex valued function from, we can say that this is the function from this interval a b to complex plane C. So this function phi is said to be integrable. Phi is said to be integrable over this interval, AB, if its real and imaginary part phi1t and phi2t are are integrable over the interval a comma b. If these two functions are integrable over this interval a b, then we can say that this complex valued function phi t is also integrable over the same interval a b. So we can write in that case a to b phi t dt is equal to a to b phi 1t dt plus iota a to b phi 2t dt. So we can write integration of this function over this interval a and b. So if this a and b are both a and b are infinite, are this function phi 1t and phi 2t have infinite discontinuity at the end point, or maybe they are discontinuous, they have the discontinuity, infinite discontinuity at some point between this a and b. In that case, this integral a to b phi t dt is called improper integral. Improper इंटीग्रल, अदरवाइज इट विल बी अ प्रॉपर इंटीग्रल. तो जैसे हम रियल लाइन में ट्रीट करते थे डेफिनेट इंटीग्रल को, क्योंकि फाई वन is a real valued function when we are integrating it over the interval a and b. So सारी property, they have the same property as we have already know about the real valued function when we are integrating them over a interval. Okay, इसके कुछ एक आध एग्जांपल्स कर लेते हैं, देन वी विल कम ऑन द अदर एग्जांपल्स. Evaluate integral a to b phi t dt where this function phi t is defined as, where phi t is defined as minus it, and this lower limit is 0 and upper limit is pi. Okay, so this is the function 0 to pi t it dt. We can write it like 0 to pi t, and in place of e to power it we can write here cos t minus I sin t dt. So we can also write it like 0 to pi t cos t dt minus iota 0 to pi t sin t dt. So we will integrate it. इंटीग्रेट करके बताइए क्या आएगी इसकी वैल्यू. टेल मी द वैल्यू ऑफ दिस इंटीग्रल t cos t and t sin t ओवर द इंटरवल 0 to t. जैसे करते थे रियल वैल्यूड फंक्शन के लिए, इन द सेम मैनर here phi t is t into cos t and phi 2 is t into sin t. You can simply imply here the integrate by parts, integration by parts. Sorry, this should be sin t. Sin t dt. These two terms will be 0. Then t sin t 0 to pi minus iota plus it cos t. T cos t 0 to pi. So sin at sin pi is 0 and sin 0 is also 0. एक second. Sin t will be plus cos t. 1 second. This will be not 0. This will be not 0. 1 second. Because it will be the cos t and 0 to pi, it will be not 0. This term will be 0 because it will be the sin t plus cos t we have to also write here plus cos t 0 to pi प्लस है कि माइनस है. एक सेकेंड. 1 सेकेंड. Sin t, this integration is minus cos t plus cos t. Okay, and then okay, so this term will be 0 plus iota pi cos pi minus 0, and this will be cos pi minus cos 0. Minus pi I, and this will be minus 2. This value is minus 1 and minus 1 minus 2. So minus 2 pi I. So it is the value of integral when we are integrating this complex function over a real interval a to b. Okay. Next is curve in complex plane. How we define a curve in complex plane? Like we define the curve in a two-dimensional plane, like y is equal to x, y is equal to x square, or ellipse like x square upon a square plus y square upon b square is equal to 1. How we define the curve, different curve in complex plane? Okay. Curves in complex plane. Actually, curve in complex plane is a function from real interval to c. If we are considering a function like phi, which is the function from a closed interval to a complex plane, then phi is called a complex curve in this complex plane C. So phi will be called a curve in complex plane. Here we are defining this curve by j. In place of j, phi, we are writing here j. So we are denoting it by z. This is zt, and zt we can represent because this is a complex valued function. So it must have some real and imaginary parts. So we can write it like xt plus iyt for all t where this t lies between the interval a and b. So in that case यही बात है जो हम यहाँ कह रहे हैं, बस इसमें फाई की जगह पे यहाँ पे क्या लिख दिया है, z. So here this z is a function from an interval to complex plane C. Then this j is called curve in complex plane, and we can represent, because corresponding to every t in this interval we will get a zt, and zt will be the member of this complex plane C. So this complex valued function can also be represented as its real and imaginary part, which is xt plus iyt. Okay, and this t lies in this closed interval a and b. So this point z is equal to zt, this point, these points z is equal to zt will trace a curve. They will traces a curve in complex plane from endpoint for this curve will be ja and jb. Endpoint for this curve will be ja and jb. तो इस इंटरवल में t अलग अलग वैल्यूज लेगा for different value of t between this interval t1, t2, t3. We will get correspondingly a point in complex plane z that will be ja, jt1, jt2. For suppose that a to b, हम यहाँ पे कुछ points लिख रहे हैं. A है, फिर after that there is t1, then t2, then t3. Actually continuously lots of point between this interval a and b, and this is b. So corresponding to this point a, we will get a point in complex plane za. Corresponding to this t1, we will get a complex point zt1. Corresponding to this t2, we will get zt2. So when we are joining all these points, so we will get a curve in complex plane. So this point zt will trace a curve in complex plane which will start from za and end at jb. So this is called the curve in complex plane. and direction of the curve will be direction of, for suppose that we have a curve like, for suppose if we are representing this curve, this is, it is our complex plane. So we are representing a curve like this. This is the curve C, where this point is JA, which is XA plus IYA, and this is the point JB, which is XB comma YB. This is the point. So direction of this curve C will be in direction in direction where T increases from A to B. So T की जो increasing direction है, that direction is called direction of this C. Okay, and it is also called the direction in which T is increases from A to B is also called the positive direction for this curve C. Okay, and if these end points coincide, for suppose at A and B, value of function is coincide. So what will happen? If this JA and JB is equal, तो उस केस में क्या हो जाएगा? If value of this function zt is same at the end point A and B, so what will happen? If this JA is equal to JB, so what will happen?
मैम क्लोज कर्व मिलेगा.
Yes, we will get then closed curve because the end points are same. Okay, so in that case we will get a closed curve. Next is simple curve. Simple curve. A curve C is said to be simple if it does not intersect itself except the end point. जैसे क्लोज कर्व होता है वो केवल एंड पॉइंट पे एक दूसरे को सेम वैल्यू लेता है. इसके अलावा कर्व अगर ऐसा है, इट इज डज नॉट इंटरसेक्ट इटसेल्फ. इंटरसेक्ट इटसेल्फ का मतलब कि वी आर गेटिंग टू डिफरेंट वैल्यू ऑफ T1 and T2 in this interval, in this closed interval A and B, we are getting two different value T1 and T2. They are not same, but image under this function J is getting same. Means curve in between is not one type. So in that case जो कर्व होगा that is not simple curve. तो simple curve होने के लिए क्या होना चाहिए? Between this end point, because I am saying that a curve except the end point, it does not intersect itself. If this curve is not intersecting itself, then it is called the simple curve. जैसे यहाँ पे हमने ये सर्किल लिया है, it is a simple curve. या कोई और कर्व इस तरह से ले लेते हैं, it is the simple curve because except the end point they are not intersecting itself. इसके अलावा और किसी भी दो पॉइंट्स के लिए it does not have the same value. So this kind of curve is called simple curve. Simple means that for every when T1 T2 is not equal, then jet T1 is not equal to jet T2. So that kind of curve is called simple curve. Next is a smooth curve. A smooth curve. Okay, for suppose that curve is defined like for T long in this closed interval A and B, and this curve is said to be smooth if this jet T is continuously differentiable and jet dash T means derivative of this z is not equal to 0 for all t in this interval. So that kind of a curve is said to be a smooth curve. Continuously differentiable means z dash t exists karta hai and it is also a continuous function, and it should not be 0 for all t between this a and b. So that kind of curve is called a smooth curve. And means that this curve C has unique tangent at each point and whose direction varies continuously as we are moving along this curve C. As we are moving along this curve C, so direction of this tangent is varies continuously and tangent at each point is unique. So that curve is called smooth curve. एक होता है हमारा पीस वाइज स्मूथ कर्व. पीस वाइज स्मूथ कर्व क्या होता है कि मे बी कि इन बिटवीन एनी पॉइंट इस इंटरवल के बीच में कोई एक ऐसे पॉइंट्स मिल जाएं या हम कहें कि इस इंटरवल ए बी को हम फाइनाइट पार्ट में डिवाइड कर दें. फॉर सपोज दिस इज ए एंड दिस इज बी and we are dividing this in finite parts, say that t1 t2 t3 t4 and so on. इस तरह से हमने इसे फाइनाइट पार्ट में डिवाइड किया है. सो इन एवरी सब इंटरवल this curve is a smooth curve. In every sub interval this curve is a smooth curve. Maybe at the end point, जो ये end points मिल रहे हैं, maybe the end point this curve is z dash t is discontinuous, क्योंकि इसकी प्रॉपर्टी होती है z dash t is also continuous, but maybe at the end point z dash t is not continuous. It means that end points are maybe the discontinuity, but this continuity is of the finite type. ये जो discontinuity होगी it must be the finite type. इसमें भी किसी की वैल्यू z dash t की वैल्यू infinite नहीं आ रही होगी. So this continuity must be in infinite type. So in that case we are saying that curve is not smooth but it is the piecewise smooth. Okay, so this is main difference between smooth curve and piecewise smooth curve. Next is contour. Okay, if a curve C, say that have a curve name is C. If C is a curve smooth or piecewise smooth. If C is smooth or piecewise smooth, and that is it piecewise smooth means that is it is consist of finite number of smooth arcs. Finite number of smooth arcs. जो piecewise smooth curve होंगे they will be like this. इस तरह से यहाँ से फिर एंड दूसरे से इस तरह से कर्व है. So that kind of curve is called a smooth curve. So this consists of finite number of smooth arc, then it is said to be contour. It is said to be contour. Okay, if a curve C, or suppose that if a curve C is defined like zt and t lies between the closed interval a and b, then its reverse curve क्या होगा. मान लीजिए ये हमारा एक कर्व है कॉम्प्लेक्स प्लेन में, डायरेक्शन उसकी ये C. इसका रिवर्स कर्व क्या होगा, ये डायरेक्शन होगी, इसकी रिवर्स डायरेक्शन हो जाए. दैट कर्व इज कॉल्ड रिवर्स कर्व. वी जनरली डिनोटिंग इट बाय नेगेटिव साइन. We are putting just negative sign before this C, then it is called the reverse of this curve C. And this is defined as, this curve minus C is defined as z is equal to z of minus t, where this t lies from minus b to minus a. So when t lies between the interval minus a to minus b to minus a, and z is defined as z is equal to minus of t. So this is the same curve. This is the same curve as this curve C, but here the direction is opposite. Here is only the direction is opposite, but both have the same curve. If अगर इन curve को हम trace करें, they will give us same curve, but direction will be opposite. It will be from A to B, and for it will be from B to A. Okay, so this is the same curve but in opposite direction. Next is for suppose that we have a closed simple closed curve C, and simple closed curve, say that this is our simple closed curve C, and this curve C, for suppose that ये हमारा पूरा complex plane है. It is our complex plane. It is our whole complex plane. So this curve C separate the whole complex plane in two distinct regions. One region will be inside this C and other will be outside of this C. और बाउंड्री जो होगी इनकी कॉमन बाउंड्री जो आउटसाइड कर्व और इनसाइड कर्व विल बी दिस C. ठीक है. So one region, this C will separate the whole complex plane in two regions, two distinct regions. One is inside this C and other is outside of C. Inside C is a bounded region and outside the C will be the unbounded region. And this result is called Jordan curve lemma. This result is called Jordan curve lemma. Jordan curve lemma. Okay. Now try a question related to the curve. We have to write the parametric representation of a simple, closed and smooth curve. Simple, closed and smooth curve. We have to write its parametric representation. It will trace a ellipse. It will trace a ellipse. Ellipse is 9x square, y square 9. So first we have to write its parametric representation, which will trace a ellipse and its direction traces ellipse in direction. First direction is anti-clockwise. Anti-clockwise, yeah, counter-clockwise. Second is clockwise. दो कर्व हैं, एक बार जो है ना सेम कर्व को पैरामीट्रिक इक्वेशन लिखनी है इस कर्व की जो एंटी क्लॉकवाइज इसको ट्रेस करे एक इलिप्स और दूसरी बार हमें क्लॉकवाइज करें. Okay, so this ellipse can also be write as x square upon 1 y square by 9 1. This is the ellipse. So its parametric equation can be write as x is equal to cos t and y is equal to 3 sin t. Its parametric equation will be x cos t and 3 sin t, where this t will travel because we have to trace the curve in anti-clockwise direction. So we can take t is equal to 0 to 2 pi. Anti-clockwise direction is also known as positive direction. So this will be 0 to 2 pi. या zt बोलें तो zt will be cos t plus I 3 sin t, where this t is like this. T will from 0 to 2 pi. This is our curve C. And you know that z dash t in that case will be z dash t will be sin t plus I 3 cos t. Yes, this will be the cos 3. And for this reason, t and 2 pi, t2 when t is lies in the interval 0 to 2 pi, you can see that in this interval z dash t is never 0, because when cos t will be 0, then at that point sin t 0 नहीं होगा. जहां पे sin t 0 होगा वहां cos t 0 नहीं होगा. So we can simply say that in the whole interval z dash t is not equal to 0. So it is not equal to 0. So it is and it's जैसे इसका डिफरेंशिएबल है, कंटिन्यूअस होना चाहिए. सो यू कैन सी दैट इट्स real part is minus sin t and imaginary part is 3 cos t, and both are entire function. ये हर जगह sin t और cos t जो होते हैं they are differentiable everywhere, so obviously they will be continuous everywhere. So z dash t is continuously differentiable and z dash t is not equal to 0 for the all t from 0 to 2 pi. So obviously it is a smooth curve. And next is it is saying that it is a closed curve. So you can see that z0 is 1 and z2 pi is also 1. So at the end point zt and zt is same. It means that it is a closed curve. Again simple के लिए बात करें, so this is also cos t and sin t. in this interval is also a 1 1 function. It means that for two different value of t1 and t2, we will get different ht1, jt1, zt1 and zt2. Okay, so it is also it is a simply simple smooth curve, smooth and closed curve. Now we have to find the parametric representation for the same curve, but direction is opposite, it is clockwise. So you know that for the reverse curve we can write it, denote it by dot c, and it will be z minus t, z minus t. So z minus zt is cos t plus I sin t, so z minus t will be, in place of t, we are substituting minus t. So cos minus t is cos t plus 3i 3 plus I 3 sine minus t. It will be minus sine t. So minus 3 sine t. In place of sine minus t, we can write minus sine t. And interval will be from minus 2 pi to 0. So this is the curve parametric representation of same ellipse, but direction is in clockwise direction. Okay. Next important topic is contour integral या line integral in complex plane. Contour integral or line integral in complex plane. In complex plane. This is same like we have studied about the line integral in two-dimensional plane. हम लोगों ने मैथमेटिक्स 1 में पढ़ा था कहीं पे लाइन इंटीग्रल, सरफेस इंटीग्रल एंड वॉल्यूम इंटीग्रल. So same way it is also defined here. For suppose that we have a curve C which is defined like zt xt plus iyt, and this t lies in a closed interval a to b. So this curve C is simple and smooth curve. So zt is denoting a simple and smooth curve. Simple and smooth curve. Here we are taking this C is simple and smooth curve C. Okay. And we have a complex valued function. We have a function f from C to C, complex plane to complex plane C. Let we have a function fz. This function is continuous function and defined at each point of this curve C. So let fz be a continuous function, be a continuous function defined at each point of this C, at each point of C. So how we will define the line integral or contour integral of this fz along this curve C? Okay. So like the line integral we have studied in mathematics 1 in a plane, in the same way we will define here. First of all, we will divide this interval A to B in a partition by choosing some point between them. So for suppose we are dividing this interval, let we are choosing a partition of this interval A and B, like A is the first points denoting it by T naught, and then we are choosing a point T1 which is between the A and B, and then T2 and so on, and last point is Tn which is equal to B. So we are dividing this interval AB in sub intervals, या कह सकते हैं we are choosing a partition for this B, क्योंकि ये it is not a unique partition, इससे बहुत infinite number of partition we can make here. So simply we are choosing a one partition here which is like this, T naught which is equal to A, and T1 T2 T3 so on, and Tn is equal to B. Okay, it is a partition of this interval A and B, and denoting this point zt on this point T1 T2, like suppose that ZTK. ZTK is image of this curve J at this point TK. We are simply denoting it by JK. So JK is the point which is the value of this curve at this point TK, where this K lies from, देखिए कहाँ से 0, 1, 2, 3 and N. So K's value is 1, 0, 1, 2, 3 and N. So we are simply denoting by JK, JTK. Okay, so now, for suppose we have a curve in complex plane. This is the curve C. This is JA. This is JB. It is a simple and a smooth curve. Between them, it is the T1 point पर इसकी वैल्यू है JT1, यानी कि इसको हम लिखेंगे J1. This will be J1. Then J2, J3 and so on. Suppose that here will be JK minus 1 and this one is JK and so on. So इस तरह से यहाँ पे वैल्यू है. And let let xi k be an arbitrary point in the interval B, an arbitrary point in the interval this interval jk minus 1 jk. So xi k is any arbitrary because there are infinite number of points between this interval jk minus 1 and jk. So we are choosing an arbitrary point between them, which is xi k. So xi k is a point lies between this interval, and we are defining a sum here, and defining a sum here as n, which is from k starting from 1 to n, f xi k into delta jk. Delta jk, say that it is 1. Delta jk is length of subinterval, length of this subinterval jk minus 1 and jk. So delta jk is length of subinterval. Yeah, delta jk is difference. अभी length इसका mod निकालेंगे तब होगा. So delta jk is difference between jk minus 1, and delta, when we are taking its mod delta jk, it will be mod of jk minus 1. Say that it is p point, this is q. So when we are saying delta jk, it is this chord pq. This is the chord pq. Okay, so it will be the length of this delta jk. Okay, here we should write mod jk. This function should be defined like this: mod of delta jk. नहीं, dj jk minus 1. नहीं, no, we will not write it. Okay, so this is the delta jk, which is the length of this chord pq. For suppose that कितने सब डिवीजन किए हमने यहाँ A से B तक, you can see that this was T0, T1, T2. So this one is one in sub interval, this is 2 interval, and this is here n interval. So we have make here n subdivision. Yeah, we can say that n is equal to number of subdivision of the interval AB is number of subdivision of interval A comma B. For suppose that if this n, which is subdivision of this interval, if this n is approaching to infinity, so what will happen? this length of subinterval. So what will happen if number of subdivision is tending to infinity? So what we can say about length of this subinterval? क्या होगा? If number of subdivision A और B एक interval है हमारा, bounded interval है. So if subdivision of this interval is approaching to infinity, so what we can say about the length of subdivision?
0.
Yes, this will approach to 0. इसमें जो maximum value जो सबसे बड़ा interval होगा, that is also approaching to 0. In that case, it will approach to 0. So in that case, if this sum Sn, when we are taking n tends to infinity, in that case, length of subdivision is also approaching to 0. And if this sum Sn, for that case, if this sum is approaching to a finite value, if this is approaching to a finite value, it is not depending, and this finite value is not depending upon choice of this partition, कि कौन सा partition हम choose कर रहे हैं यहाँ पे divide करने के लिए. It is not partition dependent, and also it is independent of choice of this arbitrary jk, this arbitrary xi k. If it is independent of choice of arbitrary xi k between the subinterval, then we will say that this function is integrable along this curve C. Then we will say that if it is independent of choice of partition, choice of this arbitrary point jk between the subintervals, yes, between the subinterval, then we can say that this function is integrable along this curve C, and this integral is called, in that case, then we say that function is integrable along this curve C, and replace this sum by the limiting value जो भी finite value आ रही है. In that case, the finite value is denoted by integral along curve C fz dz. This sum is, जो finite value होती है sum की, that will be equal to integral, ये sum जो होता है summation, it will be replaced by the integral sign, because integration क्या होता है, continuous sum होता है. So we are replacing it by integral sign, and we are saying that function fz is integrable along this curve C, and this यही जो हमारा इंटीग्रल होता है, this integral is called line integral or controlled integral in complex plane. Okay, so this is the definition of line integral and control integral. So we can say that, one second, एक second. Okay, so we can write here limit approaching to delta jk, length of this delta jk is tending to 0, then this Sn must be equal to a finite value, say that S, and this S is integral from along this curve C of fz. So this is called the line integral or control integral. Okay, and this is called the definition of integral of a function fz, limiting definition of the function. So now we will discuss some properties of this contour integral. For suppose that we have two functions fz and dz, both are continuous function and defined on a piecewise smooth curve C. Piecewise smooth curve C. F and gz are two continuous function defined on a piecewise smooth curve C, and alpha and beta are two arbitrary complex constant. ओके तो ये हमारे पास टोटल हम कंडीशन लेके चल रहे हैं fz and zz be two continuous curve, continuous function, define continuous function defined on a piecewise smooth curve C. Okay, so first of all, for suppose that C star is denoting the reverse curve, C star is denoting the reverse curve, या कह दें कि माइनस सी से डिनोट कर दें, सी स्टार की जरूरत नहीं है. So when we are integrating the same function along in reverse direction, if we are integrating this function along reverse direction, so its value is negative times of value of the function when we are integrating it in positive direction. जो भी इसकी ओरिजिनल डायरेक्शन थी उस डायरेक्शन में इवेलुएट करने पे जो वैल्यू आएगी उसकी केवल माइनस टाइम्स हो जाती है. फॉर सपोज दैट C is the curve which consists of two piecewise smooth arcs C1 and C2. For suppose C हमारा जो curve है, it is, this is sum of two curves, say that it is C1 and C2. It is joined by, this curve is made by joining end point of, एक का end point दूसरे का initial point, ये हमारा initial point, तो C1 and C2 इस तरह से join है, वो curve है C. So how we will find the line integral? It must be, in that case, fz dz must be, first we will integrate along this C1 plus integration along this C2. This is the second property. इस तरह का आपने डेफिनेट इंटीग्रल्स में भी पढ़नी हुई है. और भी प्रॉपर्टीज हैं बट I am including here these only. Okay, so one of the important thing is when the existence for the contour integral, कि कब हम कह सकते हैं कि contour integral for a function along a curve is will exist. So existence condition is fz should be continuous or piecewise continuous at every point of a smooth curve. If fz is continuous or piecewise continuous at every point on a smooth curve C, then fz is integrable along that curve. Means if fz, it is the existent condition, fz is continuous or piecewise continuous, piecewise continuous at every point on a smooth curve or piecewise smooth curve C, then fz must be integrable, is integrable along this curve C, along this curve C. Okay, suppose that C is a piecewise smooth curve which is represented like zt parametrically xt plus I times yt, and this t lie in a closed interval a and b, a and b, a and b. So we can, and fz is complex valued function, so it can also be represented like this, x comma y I v x comma y. Okay, so line integral of this fz along this curve C can also be write as u plus iv, and because x is the function of t, y is the function of t, so obviously we can think this u and v as a function of t, and we can also write it like dx, because dz will be dx plus I dy, and this can also be write as c u plus iv dx by dt plus I dy by dt into dt. Okay, and dx by dt plus I times dy by dt can also be replaced by dz by dt. We can also write in place of it dz by dt, u plus iv dz by dt into dt. या हम कहें इसको हम we can also write it like this c fz dz can also be write like fz z dash, because z is function of t, so we can write it z dash t and dt. तो इसको इस तरह से evaluate करते हैं. We will evaluate it like this. Okay. One important theorem is ML inequality. This theorem is also known as ML inequality. ML inequality. क्या है theorem? Let C be a piecewise smooth curve. Let C be a piecewise smooth curve defined as defined like this. Then modulus of this line integral along C of this function fz, it is bounded by ML. It is bounded by ML, where this L, where L is length of this curve, complete length of curve is the length of curve C, and M is the upper bound of this function fz over this closed curve C, and M is upper bound, M is a positive number such that mod of fz is always less than or equal to M everywhere on this C. It means that every point on this C, every point Z on this C, f of Z, modulus of f of Z is always less than or equal to this value M. So it is the upper bound for this function fz on this curve C. So line integral of this function fzc is bounded by this quantity, this value, which is M and L. So where M is the upper bound for this function fz on this curve C and L is the complete length of this curve C. So this inequality is called ML inequality. This is also known as ML inequality. Okay, so let's how we can prove it. छोटा सा proof है इसलिए आज ही बता दे रहे हैं. Because we have given that mod of fz is bounded by this M on C. Okay. And for suppose for any partition, हमने यहाँ पे कोई एक partition किया है इस interval AB का. So या कहें कर उसके along हमारे पास curve C का भी partition मिलेगा. For suppose A और B के n subdivision किए तो उसके along we will get the partition of this curve. Also this will be JA, J1, J2, J3, and this will last term will be JB. So when we are adding these intervals, when we are adding length of this sub interval means Z1 minus ZA, Z2 minus Z1, Z3 minus Z3. So when we are adding the length of all these sub interval, so for suppose for n partition, this length jk minus 1. Suppose that its value is L star. For particular partition, if we are choosing a partition, yes, T1, T2 and so on, B, ये particular partition के corresponding, we will get Z2, Z1, Z2, Jn. So इसके बीच की length, इस sub interval के बीच की length and all this interval, when we are adding all these value, we will get L star. इसी तरह अगर हम कोई दूसरा subdivision करते हैं, we will get another L1 dash मान लीजिए. For suppose L1 star or any other values. So this is the sum of length of chords. Okay. length of chord L star is sum of length of chords whose ends points are J0, J1, J2, J3, Jn, and so on. Okay. So when we are taking subdivisions, when we are taking this subdivision, n tends to infinity. So you know that so maximum length between them, maximum length of this subdivision is approaching to, this length will approach to 0. This length will be approach to 0. In that case, this L star, if in that case, this L star must approach to a finite value. This must approach to, because ये जो कर्व हमारा कैसा है, एक सिंपल स्मूथ कर्व है. So this value of L star must be approach to a finite value, and this finite value L will be, this L is length of, actual length of curve C. जो L star उस समय जिस वैल्यू को अप्रोच करेगी, that will be the length of this curve C. Okay, so you know that mod of fz dz, लिमिट फॉर्म में इसको लिख सकते हैं हम, लिमिट n टेंस टू इंफिनिटी mod of Sn, mod of Sn, and Sn is n tends to infinity. Sn was summation, this was the summation f xi k delta jk, delta jk, and you can also write it like n tends to infinity summation k from 1 to n mod of f xi k mod of delta jk, and we can also write it like, because we know that mod of fz is less than m, so we can also write it less than or equal to, in place of fjk we can write it less than or equal to m summation limit n tends to infinity k from 1 to n delta jk, and you know that delta jk summation delta jk is L star, so m limit n tends to infinity L star, and this is limiting value is L, so we can write here ml. So this is the complete proof of ML inequality. Okay, so I am ending this class. So today here I am ending this class, and in the next class we will continue after it. Okay.
Thank you, ma'am.